Assalamualaikum and hi. We are in the last subchapter of chapter 1, 1.3 logarithms of subject DM015. Okay, the learning outcomes in this subchapter, students should be able to define the logarithm, distinguish between ln m and log m, state and prove the laws of logarithm, change the base of logarithm, and solve equations involving logarithm. Straight to the point. What is logarithm? Logarithm is a number y where y is more than 0 for any given base a, where a is also more than 0, and is written as log y base a equal to x, where y equal to a to the power of x. Basically, the concept of logarithm involve two forms of equation. Okay, the first one is in the form of index, and the second one is in the form of log. Okay, so this one is in index form, as we have learned in last subchapter, and this one is in log form. Okay, so for every x more than 0, where y equal to a to the power of x, then log y base a equal to x, and vice versa, which is when log y base a equal to x, then y equal to a to the power of x. The main things that we have to consider in this relationship is about the base. So the most important part is we have to know how to identify the base. Which one is the base? Okay, so for this equation, okay, y equal to a to the power of x, we have learned before. So clearly this one is the base. Y equal to a to the power of x, so a is the base. Okay, so for the log form, okay, log y base a equal to x, so the smaller letter here represent the base. Let's take a closer look to the relationship. Okay, we have y equal to a to the power of x. Okay, so y equal to a to the power of x. We want to change this index form into logarithm form. So now we have identified that this is the base, so a is the base, so we want to change it to log form. Okay, so now this a will go to another side. Okay, originally a is the base of the index, will go to another side, it will become the base for log. Okay, and then y and x will remain on their original side. So when a go to the other side, it will become the base for the log. So it will become log of base a. Okay, and as I said before, y and x will remain on their original side. So log base a y, and then x will remain here equal to x. Okay, now if I have this log form, we apply the same concept as we have done before. Okay, we have log y base a equal to x. So now we want to change this log form into index form. Okay, so identify the base. So our base is a. Okay, y and x will remain on their original side. So y will remain on left hand side and x will remain on right hand side. And a will go to another side. We will move a to another side and it will become the base for another form, which is the base for index form. So y will remain, x will remain, and then a will go to another side and it will become the base for the index. That's it. Okay, that is the easiest way how to understand and to memorize how to change from index form to log form and vice versa. We try some example. Okay, if I have y equal to 3 to the power of m, I want to change it into log form. So now our base is 3. We will go to another side, it will become the base for the log. Y and m remain on their side. So we will have log y base 3 equal to m. Okay, if I give example log log 3 base x equal to k, I want to change it into index form. So x is the base. Originally is the base for the log. We go to another side, will become the base for index. 3 and k will remain on their original side. So we can have now 3 equal to x to the power of k. 3 and k remain, x change side and become the base for the index. Index or exponent and logarithms are related, as we have discussed before. The index asks how many times to use the number in multiplication, and the logarithm answers what the index is. So we can use that concept to solve the equation involving index and logarithm. These are some examples. So if we are given 3 equal to log 8 base 2, and we also have 2 to the power of m equal to 8. So we have to, based on this information, we have to identify what is m. So by considering this, we know that 2 is the base. Okay, so when it goes to another side, it will become the base for the index. So from here, we know that 2 will become the index for, it will become the base for the index. So 2 to the power of 3, we go to another side. Okay, it will become the base for the index. 2 power of 3 equal to 8. So we can just compare. We can have now m equal to 3. Okay, next example. If we are given 1 over 5 power of 2 equal to 1 over 25, and 2 is equal to log 1 over 25 base k. So from this index form, we can read that 1 over 5 is the base. So it will go to another side, become the base for the log. So 2 will remain on its position on its side. Okay, so we go to another side, so we can have now log base 1 over 5. Okay, 1 over 25 will remain on its side, so it becomes 1 over 25 here. Okay, so we have now 2 equal to log 1 over 25 base 1 over 5. So by comparing these two, clearly we can say that k is equal to 1 over 5. K is equal to 1 over 5. Okay, let us do some example for this concept. Okay, for the following, write down an expression for a logarithm in a suitable base. Okay, the first one, 1000 equal to 10 to the power of 3. Okay, identify the base. So our base now is 10. We want to change it into log form. So you go to another side, it will become the base for the index. So log base 10 of 1000 equal to 3. That's it. Okay. Next one is 1 over 32 equal to 2 to the power of negative 5. So we want to change it to log form. So identify the base. The base is 2. We go to another side, it will become the base for the log. So log base 2. Okay, 1 over 32 remain, negative 5 remain. Easy and simple. Next example. Alright, without using calculator, find the value of log 27 base 3. Okay, the way to do this one is by writing like this. Log 27 base 3. Okay, let's say the value of this one is equal to x. So you want to find what is the value of x. So the base is 3. So bring that to another side. We count the base for the index. So 27 remain. Okay, so 3 will be the base and x remain. And x will become the power. So 27 equal to 3 power of x. So by inspection, we can have that 27 is equal to 3 power of 3. So we can say that x equal to 3. Okay, the next one, log base 5 of 25. Let's say the value of this one is equal to m. So our base is 5. So 5 will go to another side, become the base for the index. So 25 is equal to 5 to the power of m. We know that 25 is equal to 5 to the power of 2 is equivalent to 5 to the power of m. So by comparing, it is clearly that m equal to 2. So log 25 base 5 is equal to 2. That is how we use the concept of log and index to solve the problem. The concept of natural logarithm. So what is actually natural logarithm? Okay, natural logarithm is logs to the base e with the abbreviation ln. Okay, ln x equal to log x base e. Okay, the only difference here is only the base. Okay, for natural logarithm we use base e. That's it. Simple. So what is e? E is the Euler's number, where the value of Euler's number e is about 2.71828. You may try to find the value of e in your calculator. Okay, so it is about 2.71828. Okay, so you can see here the difference between common log, which is log with base 10, and natural log, log with base e. Okay, for the common log, we will write log x without mentioning any base. So that means the base is 10. So log x base 10. Okay, but for natural log, we just mention ln x. So that means log x base e. That's it. That is the simple definition of natural logarithm, or we call it LON. Laws of logarithm. As listed here, we have three laws of logarithm. Okay, we will go one by one by stating the proof of each law. Okay, we start with the first law. Okay, proving the first law. So the first law is log m base a plus log n base a equivalent to log m times n base a. Okay, we will start our proof by letting log m base a equal to x and log n base a equal to y. Okay, now we change this one into index form. So a will become the base of index, so m equal to a to the power of x and n equal to a to the power of y. The next step is I want to multiply a to the power of x and a to the power of y. So I multiply a power of x times a to the power of y. So because of a power of x is equivalent to m, so I put m here. And because of a power of y equal to n, so I put n here. So a power of x times a power of y is equal to m times n. By applying the rules of indices, you can have now a to the power of x plus y equal to m times n. N. Okay, now I have this one as in index form. So let's change to log form. So a is the base, go to other side will become the base for the log. So I can have x plus y equal to log of base a, log to the base a of m n. As a conclusion, as we substitute before, x is equal to log m base a and y is equal to log n base a. So we can have final solution as log m base a plus log n base a is equal to log mn or m times n base a shown. Second law, we will apply the same techniques to prove the second law. So the second law is log m base a minus log n base a is equal to log m over n, or m divided by n base a. Okay. The difference between law number 1 and law number 2 is the operation here. Just now we have addition, now we have subtraction, and just now we have multiply, and then now we have divide. Okay, we will use the same techniques. So we let log m base a equal to x and log n base a equal to y. So a to the power of x equal to m and a to the power of y equal to n. Okay, now instead of multiply a power of x and a power of y, now I want to divide a power of x divided by a power of y. So equivalently we have m divided by n. Okay, so applying the rules of indices, a to the power of x minus y is equal to m over n. And then change it into log form. We can have now x minus y, x minus y equal to log of m over n base a, and conclusion x minus y, meaning that log m base a minus log n base a equal to log m over n base a. So that is our final solution, which is the proof of this law. Now we move to the third law. We want to prove the third law. So the third law is log b and base a is equal to log b base a, is equal to n times log b base a. For this law, it is very easy to memorize this law. This is just, you can just bring n to the front. From power, it will become the multiplier. Okay. So now, we let log b power of n base a equal to, let's say, z. Okay. And then we change the log form into index form. And then we can have b to the power of n. So base, we go to the another side, we become the base of index, so a to the power of z. Okay. And then we want to eliminate the power of n for the b. So b n. If you want to eliminate the power, just power of 1 over n. Okay, apply for the both side. You can have now 1 over n as well, the power of 1 over n as well. So now we will have b equal to a to the power of z over n. Okay, now we change this form of index into logarithm form. So a is the base, so we bring to the other side, we will have the base of log. Okay, so log base a of b equal to z over n. Okay, so we can just bring n to the left hand side. We can have now n log b base a equal to z, and we can end up our solution as n log b base a equal to log b power of n base a, as z is equal to log b base n power a shown. A gentle reminder for you guys about laws of logarithm. To apply the rules or the laws of logarithm, all logs must be to the same base. This is very important. Okay, we can see now the example for each laws here. Okay, take a look here. So we have addition here, so this one will be multiply. Subtraction here, this one will be division. Okay, and then we have power here, x to the power of 4. We can just bring the power of here to the front, it will become the multiplier. Okay, and I want to highlight the same base here. All the base using here are the same, which is, if you want to apply the laws of logarithm, okay, to add between log, okay, we must have same base, okay. Same goes to second law here, we must use same base. Then only the laws of logarithm can be applied. We go to the next reminder for you guys. Okay, this is the reminder for law number 1 and law number 2, which is log m base a plus log n base a equal to log m times n base a, and the second one, log m base a minus log m base a equal to log m divided by n base a. Okay, what I want to highlight here, we have two things to be remembered and always put in your mind. The only operation allowed between operation allowed between log are addition and subtraction. Okay, and the only operation allowed in the bracket, as you can see above, are multiplication and division. Okay, so we have operation between log. Okay, the allowable one is addition or subtraction. Okay, so the operation inside the bracket, the allowable one is multiplication or division. Other than that is not acceptable. Now we will see some common mistake done by the students, hopefully not you in the future, about law number 1 and law number 2. Okay, some students put log m base a times log n base a equal to log m plus n base a, and log m base a divided by log n base a equal to log m minus n base a. Okay, what's wrong with these two equations? Clearly you can see here multiplication and division, and clearly we can see here addition and subtraction is not located on the right place. Okay, so we cannot have multiplication and division between the log. Okay, the operation between the log cannot be multiplication and division. And also you see here inside the bracket we cannot have addition or subtraction. So this equation these equations are not acceptable due to loss of logarithm. The next common mistake done by the student is these two. Okay, so to apply the laws of logarithm, so it is okay to have addition and subtraction between the log, but the wrong one here is about these two. Okay, so for multiplication and division, it cannot be between two log, it must be in the bracket. Okay, as we have discussed before. So these two equation also not acceptable due to loss of logarithm. Yes, it seems very simple mistakes here, but be extra careful with this mistake as you might do the same mistake as well. Pay more attention about the operation between the log and the operation inside the bracket due to loss of logarithm to avoid this kind of mistakes. Properties of logarithm. You can see now we have four properties of logarithm. Okay, we will look at two types of logarithm. First is log with base a, and second one is log with base e, or natural logarithm. Okay, the first properties is log 1. Okay, so log 1 to any base, we will have the solution as equal to 0. So log 1 base a or log 1 base e or log 1, the result will be 0. That one is property number 1. Property number 2 is if we have base, sorry, if we have these two is equal, a and a is equal, then the value will be 1. So log a base a will become 1. Okay, log e also equal to 1. This is because this is log e base e. So log e base e equal to 1. Okay, another two property is log a power of x base a equal to x, log e power of x equal to x, a to the power of log x base a equal to x, and e power of log x equal to x. Example number 1, expand the following. Okay, so to expand log 5x base 5, first is look at the 5x. So 5x I can write as 5 times x. Okay, so 5 times x in the bracket, we will apply law number 1. Okay, so apply law number 1, we will have log base 5 plus log x base 5. So apply property of indices, log 5 base 5 equal to 1 plus log x base 5. That is the answer. Okay, second example, ln e to the power of 3 over 7. Okay, so ln e to the power of 3 over 7, okay, we can put e power of 3 over 7 in the bracket, so we can have division in the bracket, so we can apply law number 2, right? So apply law number 2, operation between the log, or we can use here ln, is subtraction. So you can have ln e power of 3 minus ln 7. Okay, take a look at ln e power of 3. Now we can apply law number 3, which is 3 ln e minus ln 7. So I apply law number 3 here. Okay, so apply the properties of indices. Ln e is equal to 1, so I can have 3 minus ln 7. So 3 times 1 equal to 3 minus ln 7. That is the answer for example 2. Example 3. Now we have ln set x. So basically ln base set x is equal to ln x to the power of 1 over 2. Okay, we have the power of x here, we can bring it to the front to become a multiplier. So we apply law number 3. Now we can have 1 over 2 ln x. Okay, we proceed to the next type of example. Okay, given log 2 or log 2 base 10 equal to 0.301 and log 6 equal to 0.77. Okay, hence we are going to find log 12 by using these two information. So we must use these two information to solve log 12. So log 12. So we must consider 2 and 6 to solve log 12. So what is the relation between 12 and 2 and also 6? Okay, so obviously we can say that 12 equal to 2 times 6. So log 12 is equal to log 2 times 6. So multiplication in the bracket, so we can apply law number 1. So log 2 plus log 6. Then we can have log 2, we just copy the value of 0.301 plus log 6 is 0.778. So the answer will be 1.079. Okay. Second example, log 36. So log 36, if we want to relate with the information given, we can have log 36 is log 6 squared. Okay, so we have 2 as a power, we can bring it to the front by using law number 3. So we can have now 2 log 6, and log 6 is 0.778. So the answer would be 1.556. Okay, we move to another set of example. Write the following as single logarithm. Now we have log 8 minus log 6 plus log 9. Okay, so clearly we must use law number 1 and law number 3. Sorry, law number 1 and law number 2 as we will get involved with addition and subtraction. So consider these first two log here. Okay, so log 8 minus log 6, by applying law number 2 involving subtraction, we can have log 8 and 6, so 8 over 6 in the bracket plus log 9. Then now we have another 2 log with addition as an operation. So now we apply law number 1. Okay, so this is log 8 over 6. Okay, sorry, this one is okay, 8 over 6. So in the bracket we will have multiplication, we multiply with 9. So now we will have 8 times 9, 72 over 6 equal to 12. So the answer will be log 12. Okay, next example, 2 ln x plus x minus ln x equal to, so for the first ln here, you can see this is multiplier, so we can consider law number 3. So we can bring it up to become the power of x plus 7, the power for x plus 7. So we can have now ln x plus 7 to the power of 2 minus ln x. Now we have 2 log or ln here with subtraction as our operation. So we can consider law number 2, which is ln x plus 7 everything squared divided by x. So in the bracket we will have division. Okay, we cannot simplify anymore, so we can just stop it here. Change of base. In logarithm, we can change the base of that logarithm from a base to another base. Let's say if you want to change from base A to base B in logarithm, we have our own formula. So the formula is log m base A is equivalent to log m base B over log A base B, meaning that we have originally we have base A, and then we change this logarithm into the form of base B. So the formula is very simple and easy to understand. Okay, so this is the original base, so B now will become the new one. Okay, so we just put log base B in the numerator and log base B at the denominator. Okay, and this m will go to the numerator and this base A will go to denominator. So that is an easy way to understand and memorize this formula. Okay, let's say if I have log 5 base 3, okay, I want to change it into log base 10. So just put log base 10 at the numerator and denominator. So 5 go to the numerator, so log 5 base 10, and 3 go to denominator, so we get log 5 base 10 divided by log 3 base 10. Now if you want to evaluate this log, the only way to evaluate the log is by using log of base 10. Because of log of base 10, we can find the value in calculator. So for this one, we must change it into log of base 10. So log base 10 over, so will be log base 10. So 5 will be in numerator and 3 will be in denominator. Okay, so we can calculate directly from the calculator and you will get 1.4650. Same goes to log 10 base 5. So we change into base 10. So this is equivalent to log 10, log 10. So 10 will be at the numerator, 5 will be at denominator. So log 10 base 10 will be 1 over log 5 base 10. So we just find the value using the calculator, you will get 1.4307. Express the following as a single logarithm to base A, base 2. So it is stated that the answer must be in log base 2. So every base now we have to change from another base to base 2. Okay, so look at the question here. So log x base 2, this one already base 2. So we don't have to consider to change it into another base. But now we have log x base 8. So this one we have to change it into base 2. So this is equivalent to log x base 2 plus, okay, change it into base 2. So log base 2, log base 2. So x will be on the numerator and 8 will be at the denominator. Okay, continue. Log x base 2 plus log x base 2 over, basically 8 is equal to 2 to the power of 3. So we write 2 power of 3. Okay, so this one will become plus log x is 2. So 3 we can bring it to the front by applying law number 3, and log 2 base 2 equal to 1. So everything here will be 3 times 1 equal to 3. Okay, continue here. So now we have log x base 2 over 1 plus log x base 2 over 3. So it is equivalent to log x base 2 plus 1 over 3 log x base 2. So 1 over 3 plus 1. 1 over 3 plus 1 is equal to 4 over 3. So the final answer will be 4 over 3 log x base 2. So that is our final answer in base 2. Express the following as a single logarithm to a suitable base. Now the base is not given, so we have to think what is a suitable base to be used as our final answer. Okay, so now we have log 81 base 5 divided by log 27 base 5. Remember, we cannot apply laws of logarithm because the operation here is not plus or minus. It's not subtraction or addition. So we cannot proceed with laws of logarithm. So we have to think what is the suitable base to be used for this solution. So now take a look at 81 and 27. 81 and 27, both of them are multiples of 3. So this one, 81, is 3 to the power of 4. And 27 is 3 to the power of 3. So now we decide to use base of 3. Okay, so everything we change to base 3. Log base 3 81 over log base 3 5 divided by log base 3 27 over log base 3 5. Okay, so if we have division of a fraction, you can just change into the form of multiplication. So log base 3 81 over log base 3 5 times log 5 base 3 over log base 3 27. Okay, you can eliminate these two and we will have log 81 base 3 over log 27 base 3. Continue the solution here. Okay, we know that now log 81 base 3 over log 27 base 3. Okay, so 81 is 3 to the power of 4. So this one will be 3 to the power of 4 base 3 over log 27 is 3 to the power of 3 base 3. Okay, now we apply law number 3, laws of properties, law of logarithm number 3. So bring 4 to the front, we can bring 3 to the front. So we can have 4 log 3 base 3 over 3 log 3 base 3. By applying properties of logarithm, log 3 base 3 is equal to 1. So 4 times 1 is equal to 4, 3 times 1 equal to 3. So the final answer will be 4 over 3. Solving logarithmic equation. So you can just go through the example and apply all the properties and laws that we have learned before. So the first example is find the value of x if 7 to the power of x equal to 8. Okay, so 7 to the power of x equal to 8. Okay, so to find the value, the easiest way to find the value of any log is by considering log base 10. So we log both sides with log of base 10. Okay, so we log both sides. So log 7 to the power of x equal to log 8. Okay, so now we have log 7 to the power of x. So applying law number 3, we can bring this x to the front. We can have x log 7 equal to log 8. At the end, you can just take log 8 divided by log 7. So you can just use the calculator. Log 8 base 10 divided by log 7 base 10, you will get x equal to 1.069. That's it. Next example. Find x if ln x equal to 4.7. So basically ln x is equal to log x base e equal to 4.7. Okay, you can just use the basic concept of log and indices. So e here can go to another side and become the base of indices. So now x remain on that side. So e to the power of 4.7. So that is the answer. Solve the equation of log x base 2 plus log x minus 7 base 2 equal to 3. So now we have two log with the same base and the addition as an operation. So clearly here we can apply law number 1. So now we will have log x base 2 plus log x minus 7 equal to 3. Okay, so apply the law number 1. So we will have log base 2 in the bracket. So x multiply with x minus 7. So x minus 7. Everything equal to 3. Now we have log on left hand side and 3 on the right hand side. Now we can just apply the basic concept of log and indices, same as previous example. Okay, so this base we can change into indices. So these 2 as a base, it can go to the other side and become the base for indices. So x minus 7 will remain on that side, and 2 will become the indices, the base, and 3 will become the power. Okay, so from here we can have x squared minus 7x minus 8 equal to 0. Okay, factorize, you will get x minus 8 x plus 1 equal to 0, and at the end we will get x equal to 8 or x equal to negative 1. And if you check x equal to 8 and x equal to negative 1, you will only allow the answer x equal to x. So x equal to 8. by substituting x equal to 8 and x equal to -1 in the original equation to check whether the left hand side and right hand side are the same. So you will get x equal to 8. Now I am showing to you the checking part. So this is the original equation. So we want to check x equal to 8 and x equal to -1. Which one is acceptable? So we try with x equal to 8. So our left hand side, when x equal to 8, okay, our left hand side is equal to log 2 log base 2 8 plus log base 2 8 minus 7 equal to 1. Okay, so we have log 8 base 2 plus log 1 base 2. Okay, log 1 base 2 is equal to 0. So this one is log base 2 2 power of 3 plus 0 here. So we can have 3 times log 2 base 2. So this one will be 3. And we already know the right hand side equal to 3. So this is right hand side and this left hand side. So for the case of x equal to 8, left hand side equal to right hand side. So x equal to 8 is acceptable. Okay, so now we try for a case of x equal to -1 here. So what will happen to its left hand side? So left hand side now is equal to log base 2 of -1 plus log base 2 of -1 minus 7. Okay, if we press the calculator, you will find that log to any negative value is undefined. So we cannot proceed with this calculation. So we can just state this is undefined. So left hand side is undefined, right hand side is equal to 3. So left hand side is not equal to right hand side. So x, we cannot accept x equal to -1. So x is not equal to -1. And we can accept x equal to 8. Solve log 2x minus log 3x plus 1 plus log 9 equal to 0. So we can start with looking at the base. So now all the log here is using base 10. So nothing for us to change the base. So we proceed with this one by applying law number 1 and law number 2. So we can have here log 2x divided by 3x plus 1, applying law number 2. So plus log 9 equal to 0. Okay, now we apply law number 1 because we have addition here. So log 9 times 2x over 3x plus 1 equal to 0. We have learned in the properties that log 1 to any base will give us the value of 0. So we can say here everything in the bracket here is equal to 1. This is because log 1 equal to 0. Therefore 9 times 2x will be 18x over 3x plus 1 equal to 0. Sorry, equal to 1. So 18x equal to 3x plus 1, 5, 15x equal to 1, so x equal to 1 over 15. That is the answer. So our final example for this video. Okay, solve the equation log x base 3 minus log 3 minus 4 log 3 base x plus 3 equal to 0. As we can see here, we have two log here with different base. So base 3 and base x. So I decide to use base 3 in our solution. So I have to change the base x here into base 3. So now I will have log x base 3 minus 4, everything put in the bracket. This one will be apply the change base formula. You get log 3 base 3 and log x base 3 plus 3 equal to 0. So what's next? We want to eliminate the log x base 3 in this denominator. So everything here, all of the element in the operation, we multiply with log x base 3. Okay, so log x base 3 times log x base 3, we will get log x base 3 all squared. Okay, so when I multiply this one with log x base 3, so I can eliminate log x base 3 here and log x base 3 here. So I will end up with 4 times log 3 base 3, which is equal to 1. So 4 times 1 equal to 1. And then plus 3. So 3 times log 3 log x base 3, I will get 3 log x base 3 equal to 0. Okay, to proceed with this one, the idea is we will use quadratic equation by letting log x base 3 equal to y. Okay, when we let log x base 3 equal to y, we will have y squared minus 4 plus 3y equal to 0, because this is y, this is also y. So y squared minus 4 plus 3y equal to 0. So y squared minus 4 plus 3y equal to 0. Or we can write y squared plus 3y minus 4 equal to 0. So next step, we just have to factorize. You can just use your calculator. You factorize, you will get y minus 1 and y plus 4 equal to 0. So now we will have y equal to 1 and also y equal to negative 4. Right? So back to our substitution just now. We let log x base 3 equal to y. So when y equal to 1, meaning that log x base 3 also equal to 1. Okay? And when x equal to when y equal to negative 4, so log x base 3 also equal to negative 4. Okay, you can just apply the basic concept of logarithm. So 3 go to the other side will become the base for the index. So x equal to 3 to the power of 1. So x equal to 3. Right? So for this one, x equal x equal to 3 to the power of negative 4, so x equal to 1 over 81. So our next step is we have to do the checking part to verify which one is acceptable. So now we have to check in our original equation, log x base 3 minus 4 log 3 base x plus 3 equal to 0, whether x equal to 3 and x equal to 3 to the power of negative 4 or 1 over 81 acceptable or not. Okay, so we start with x equal to 3. For the case of x equal to 3, so when x equal to 3, so left hand side, okay, this one, all of this is left hand side, this one is right hand side equal to 0. Okay, so when x equal to 3, our left hand side equal to log base 3 minus 4 log 3 base 3 plus 3. So this one will be 1 minus 4 log 3 base 3 equal to 1 plus 3. So 1 minus 4 negative 3 plus 3 equal to 0. So left hand side equal to 0, right hand side equal to 0. So we can conclude that left hand side equal to right hand side. Therefore, x equal to 3 is acceptable as the solution for the question. Now we have to check for the case of x equal to 3 to the power of negative 4. So when x equal to 3 to the power of negative 4, we substitute this value into the equation, log 3 base log x base 3, so log x base 3 minus 4 log 3 base x plus 3 equal to 0. Now our left hand side will be log base 3 to the power of negative 4 minus 4 log, so x is 3 to the power of negative 4 base 3 to the power of negative 4, 3, okay, and then plus 3. So you can bring this one to the front, negative 4 log 3 base 3, and for this one we have to change the base, so minus 4, put everything in the bracket, so log 3 log 3 negative 4 plus 3. So negative 4 times log 3 base 3 will be negative 4. So negative 4 minus 4. So log 3 base 3 equal to 1. Okay, so this one is just the same of this value. So this one will be negative 4. Okay, plus 3. Okay, we proceed. So this one will be negative 4. So negative 4 times negative 4 here, divide by negative 4 here, we will get plus 1 and then plus 3. So negative 4 plus 1 plus 3 will be 0. So left hand side equal to 0. And we already know the right hand side here also equal to 0. So left hand side equal to 0. And right hand side equal to 0. So we can conclude that left hand side, therefore left hand side equal to right hand side, and we can make a conclusion that x equal to 3 to the power of negative 4 is also acceptable for our solution. Final answer for our final example here is x equal to 3, and also x equal to 3 to the power of negative 4. Thank you.